Okay, everybody, are you ready to go? Can I have some attention, please? Thank you. Okay, so I want to talk to you about smart contracts and give you a little bit more detail. I work for a company called XAIN. We're based in Berlin. We're involved in blockchain and AI, particularly in getting blockchains to work on IoT devices. We have some of my colleagues here today. Well, one anyway. The other one's disappeared. Okay. What I would like to cover, I'll give you a quick overview. Then I'll look at Ethereum smart contracts in particular. I'll give you some examples of how smart contracts have been used in the real world, and then what happens when they go wrong. That's what people tend to find more interesting. Okay. So whenever anybody starts to talk about smart contracts, they tend to say two things about them. One is they're not smart, and secondly, they're not contracts. And I think the kind of confusion about what smart contracts represent comes from a little bit about their history. So there was two approaches really that came to the development of smart contracts. So Ian Grigg in the 1990s, he started talking about Ricardian contracts, and this was very much based on the idea of templating legal documents. So you could have a template for a legal document, and then you could adjust the terms slightly and use this again and again and automate some legal documents. Then Nick Szabo, later in the 90s, took a more computational approach and saw them as being a way of automating, just being like pieces of code and automating something. And I think those two approaches kind of got mixed up when people started talking about smart contracts, and this leads to some confusion. What I will be talking about today, particularly when I'm talking about Ethereum, I really am just talking about pieces of code. There is no legal standing in a smart contract unless you put it there yourself. Okay. A number of platforms around that you can use for smart contracts now. So Ethereum is perhaps the well-known, but there is also Hyperledger, which very much focuses on the enterprise. They use chain code in their Fabric platform. There's also Lisk. Rootstock is developed to get your as a side chain on Bitcoin. And a more recent one, Cardano. They've got a client written in Haskell. But I'm really just going to be talking about Ethereum today. Okay, so what I'll talk about the contract, I want to begin with talking about what it's made up of, and then we'll talk about the life cycle. So what it's made of, like it has an address, so similar to any wallet address on Ethereum, but it also has some storage, it has some code, and then like a wallet address, it can have balance. So your smart contract can hold some value in the form of Ether. This is what a smart contract looks like. So the source code. So at the top I've got an address, some source code that's going to make up the smart contract. That gets compiled into bytecode like this, and that is what is stored on the blockchain. Within the contract itself, if you look at this source code, a bit on the top here, we have some variables. That effectively is a storage in the contract. So if you look at the life cycle, thank you. Creation. So if you imagine Alice wants to write a smart contract, what she will do is she will write some source code and compile that into bytecode, and then she will send that to a local node on the network. That local node will then gossip that contract around as in the form of a transaction to all the other nodes on the network. At some point it will be picked up by a miner, mined into a block, and then that block will get passed around, and then everybody will have a copy of that contract. In terms of how to use that, we think of Bob. He wants to use this contract. He wants to call a function. So he will create a transaction that will specify the function in that contract that he wants to call, and any arguments he wants to pass to that function. He will send that transaction into the network. Again, he will get gossiped around so that everybody gets that transaction. It will get picked up by a miner, mined into a block. That block will get passed around, and at that point, everybody will be able to run that transaction. And the important thing to remember is that everybody on the network will run that piece of code at pretty much the same time. So everybody will run exactly the same thing at the same time. They will have the same starting point, so they should have the same end point of the the state of the machine. So if you're writing a contract, there are a number of, on Ethereum, there are a number of languages you can use. The most popular is Solidity, and here's an example of it. Looks like JavaScript if you're used to that. It's quite easy to read. I guess it was probably chosen because it meant that a lot of developers could get into this area quite quickly. But there's also Viper, which looks like Python in its syntax. There's LLL, which looks like Lisp. It's a lower level language. A newer one is Bamboo, or if you're really adventurous, you can write bits of assembler code as well. And you can mix the assembler in with Solidity if you want. Bamboo, so that's a more recent one. It tries to make it more secure, so it has very explicit state transitions, and it avoids reentrancy. So the attack on the DAO was a reentrance attack, and so Bamboo avoids that. So it's a bit designed for security, I think. Once you've written your source code, you'll compile it and get some bytecode, and that's what is stored on the blockchain, all except the constructor. So in this example, we have the contract is called myToken. It has a constructor. That constructor is only run when the contract is deployed, so it is not needed after that. So when the contract is actually deployed, the constructor is not included in the bytecode that goes on the blockchain. I guess some of you are familiar with Solidity. Has anybody used any other language? No. Okay.
Question.
Yeah.
So all of the other languages, I mean, obviously assembler, they're all Turing complete.
Yeah, as long as you believe that. Yeah, I mean, there's the question of gas, so it's kind of quasi Turing complete, but yeah, they are.
Yeah, but principally.
Yeah, exactly. Yeah. Okay, so and then those will. If you look on the EVM, what you see, I mean, this is just looking at it from the assembler point of view, you just get some operations, some opcodes. You can read those if you want. This is just adding 4 to a number, I think. Yeah. And it's all the EVM is stack-based, so it's just putting things on and off the stack and putting things into memory. Okay, so question of upgrades. So in effect, when you write a smart contract, so you've put it there onto the blockchain, effectively you can't change that. And for developers, this is extremely annoying because whenever you're developing code, you want to be able to change it, you want to be able to upgrade it to add some extra functionality. This quote is from the Ethereum website, and so this is really their view of how smart contracts should be running. So the idea is that they're going to run exactly as programmed. And I think this is perhaps the real reason that we can't have upgrades on Ethereum, because in theory it could be possible that you could upgrade the code. So the smart contract itself, it has an address, and it has some code associated with that address. It would be possible in theory to then change the code that is at that address if you wanted to upgrade the contract, but we can't do that. And I think the main hurdle to that at the moment is just one of security. If people could change code easily on the blockchain, on Ethereum, then it would leave you open to a lot of security problems. People could change your code. Whereas at the moment, you know that your contract is out there, it can't be changed, so you know it's going to run exactly as you programmed it. People can look at this. People can look at the source code that you have published and can understand exactly what it is that they're running when they run your contract. So at the moment we can't do it. It is possible in theory. It would be nice to see. Continuing on the life cycle of a contract, there's the idea of self-destruction. So if you decide that your contract, you don't want it to work anymore, maybe it's got a security flaw, or for whatever reason you don't want it to run anymore, you can you can use a self-destruct keyword, and what that does is it effectively reclaims the storage from that contract, and gets rid of any memory. Any ether that is being held by that contract is then passed back to an address that you can specify, but effectively the owner. But if you do this, you should not assume then that that contract has disappeared, because, as it says here, nodes may choose to keep the original version of that contract around. You won't be able to call that code, you won't be able to run the functions in that contract, but people will still it will still be in the history of the blockchain. The transactions will still be there. So if there's been a security flaw, don't assume that vulnerability has disappeared. People will still be able to see what it was. You have a question?
Does it cost gas? Because if I want to read my storage?
So you get a refund. When you give up storage, you'll get a refund. So you'll probably get a refund for calling self-destruct. Yeah.
What's the purpose of not every client doing pruning? I mean, obviously that doesn't pertain to a fork, right? Where a group decides that they want to run an old client or a different client. So why is it not enforced that all the clients have the same state?
I think really it's just the fact that the clients are just going to follow the yellow paper and the specification from that. How they actually implement the client itself is up to them. So they've left it fairly loose, I think. So even though pruning is probably a good idea, you can't really rely on the fact that a client would do that. It's really up to them. Someone might write a fairly bad client and just not do pruning. Yeah, whatever. Yeah. Okay, so some restrictions on contracts. So I hadn't mentioned gas really but this is needed. If you imagine we have a piece of code that is being passed around a network and everybody is running some function in that code, there's the potential there for a denial of service attack. You could create a function that just goes into an infinite loop and then call that function and then effectively do a DDoS on the network. So to prevent that, we have the idea of gas. So every operation that runs on Ethereum, every step has a gas cost, and you need to pay for that gas up front and pay for that in Ether. If your contract runs and you haven't paid enough gas for the function to complete, you'll get an exception and the state will be reversed. The state will revert back to how it was before the transaction. There's also a limit to the amount of gas that can be used in a block. So even if you pay a huge amount of Ether up front, you can only actually run a certain amount of computation. So this is all to prevent people doing too much computation or trying to store too much information on the blockchain. That's the first restriction. The second one, determinism. So we want our blockchain we need to reach consensus about the state of our virtual machine. And to do that, we need to make sure that all the operations we have running in our virtual machine are completely deterministic. So the state of the virtual machine at any time has to be exactly the same on each node in the network, exact down to the bit. So for that reason, yeah, every function we run has to be completely deterministic. The other thing we'll talk about, I'll mention in a second, are oracles. So I mentioned gas. This is a website that will show you, give you details about gas and tell you the gas price at the moment and how much gas you need to supply if you want your transaction to go in a certain time. Determinism, what this means is that we're not allowed to have random numbers, because if we had a random number, each client could then end up with a different state in their virtual machine, and then we would have a failure of consensus. So that's something you can't have. You cannot access the local file system or the operating system, because again, the clients could have a different view, and they could end up with different state. And you cannot access the network, because again, it could be a difference in the view that a client has. So your virtual machine cannot go out and find out some information from the internet, because maybe one client could do that and maybe would get some information, and other clients maybe behind a firewall and wouldn't be able to do it, and they would end up seeing different views. You'd end up with different state, and you'd fail consensus.
Question.
Yeah.
Are there any ways to create an outside, random number oracle or something whereby then the virtual machine has access to a random number that was created in the past and is referenced by some whatever hash?
Yeah. So I mean, oracles. So this is what you're referring to. So to get around the idea that you cannot go out and get information, people use oracles. So this is some third-party trusted source that you use to get some information for you and to pass that into your contract. And so, yes, you could do that. You could go use something like this to fetch a random number and then pass that into your contract. But random numbers in general are difficult. And if you're designing some application, particularly gambling applications, it is difficult to do in a way that cannot be gamed. So, for example, you may pass in some random number into your contract fire a transaction. So that will work in the sense that that is allowed, and all the nodes will get that random number, and that will be able to be used in your contract. But the problem is, one, everything that you do in a transaction is visible to everybody, so everybody will be able to see the random number that you sent in. And also, miners can choose which transactions to allow into a block. So if they see that a transaction is coming in that's going to win some game, they could decide to withhold it and put in a transaction of their own instead. So effectively implementing random numbers is extremely difficult. Yeah. Go on.
You say the smart contract can't fetch external data. Is it always the way to workalize to get some trigger data, for example, to execute the smart contracts, or they need some external data to execute it sometimes?
Yeah, so any smart contract, the execution starts by someone externally starting a transaction, which will then call a function which will execute on the virtual machine, and the data. Yeah, the external data, if you need that, you have to get someone else to push that in as a transaction. And that is to ensure that everybody gets the same view, gets the same data. Yeah.
Can you give me an example, which is like a standard case for the call of an oracle?
Yeah. So if you want to go and get some financial data, you want to get a stock price. If all your nodes did that independently, they would all get different prices they would do it at slightly different times, they get different prices. So what you do is you get a service. So for example, this company, Oracleize, they will do this for you. They will go and get data for you. You tell them your contract and how to send a transaction to it, and you then arrange that, say, every 30 seconds, they will push a transaction into your contract, pushing in the price of some stock or something like that. Yeah. And so they will send the transaction in, and then everybody will get the same view. Yeah.
And as you mentioned, I always need like fixed, I need some kind of data which is variable. I need a fixed data point somewhere, maybe from a time series or somewhere.
Yeah. So you set that up with Oracleize, so they're off chain. They can set up the service to do that, and they will go away and get some data from wherever. I mean, maybe they will choose a number of services to get it from and aggregate it, but then they will put that into a transaction and send that transaction into your contract. Yeah.
How would it look like? Give us an example.
Don't on the slides, but it's just a callback in your contract. You just send them you just set up a URL of where you want what you want to be the data source to be, and then they effectively call back into your contract. Yeah. So you set it up with them, and then did. And you have to pay them for it as well, of course. They have a fee.
One more question.
Yeah.
So it says there's no need for an additional trust lines as our good behavior is enforced by cryptographic proofs. How do they do that? I mean, how can they prove that they talk to the right guy and get the right data?
This is up to you. This is a company called Oracleize that did this blurb. So you really have to look into what they're doing and work out if you can trust them or not. They do have some cryptographic means by which they verify the data. I think they give you some means of doing that, so you can maybe doing some hash values of the data and comparing it, so you can decide that they haven't tampered with it. But yeah, you have to decide to trust them. Yeah, but they're not the only one. There are other people doing it. Microsoft have set up a marketplace so that people can set up their own oracles, and then you could go and choose one oracle over another, and you would pay different people if you trusted their data. But yeah, it does go against the kind of the blockchain idea that of trust, really. But yeah, you have to go off chain and decide to trust the oracle if you want to get some data. Okay. As well as contracts, you can create libraries on Ethereum. So if you have some code that is going to be needed by a number of contracts, there's going to be some utilities. For example, on Ethereum, in Solidity, you can't do any string manipulation, which is really annoying. So people have written libraries to do string manipulation. And you can put those onto the Ethereum blockchain. You just need to supply an address, and then other contracts can call your libraries. Precompiled contracts are interesting. So there are some functions that will be very difficult to run in bytecode. They would require too much gas, and so there are a handful of precompiled contracts on Ethereum, and these do, for example, cryptographic functions. And the way these work is that there's a specific address that they are given, And then if your contract calls that address, instead of actually going and finding the bytecode and running a traditional contract that you would find on the chain, it calls into the client and they implement the function themselves natively in whatever language they're written in. So this is an example from Geth. So this is written in Go, implementing this function. So if you're trying to do the SHA-256 hash from your contract, rather than actually running some bytecode, if you run it on Geth, it will go into this function and run it using Go. So there are a handful of these, really just to get around the fact that some things are too expensive in terms of gas. Example use cases. So talk about Porsche. So XAIN did a project pilot with Porsche to put the blockchain into cars, or IoT devices in general are a very good use case for blockchain. But there are many other use cases: supply chain, healthcare, energy voting, digital asset management, and what a lot of people are interested in nowadays, ICOs, of course. But they're not the only use for smart contracts. Okay, things that can go wrong. So I do tell people when I'm teaching about solidity of smart contracts to really think, if they're deploying a contract, really think of it in the same way you would think if you were writing some software that was going to be used, say, for a satellite or in some medical machine or something. It's good. The fact is that it's going to be really costly if you do something wrong. So you have to be super careful and make sure you've thought of every conceivable problem that could happen and the way that your contract could be attacked. And of course, that didn't. People have had problems. So one of the first ones, there was the very iconic one with the DAO, which is over almost 2 years ago now. This was a crowdfunding idea, a decentralized autonomous organization, which raised a huge amount of money. At one point, it held $200 million in Ether, and that was held in the contract. So that contract had complete control over that Ether. And someone worked out a vulnerability in it and exploited it and started draining the Ether out of the contract. It's a long story, so I'm not going to tell you all the details, but eventually they got away at the time with what was worth about $50 million worth of Ether. And it was due to a re-entrancy problem.
Are they still locked?
So it's a long story. So there was a hard fork, so that didn't happen on the main Ethereum network. That didn't happen. On the Ethereum Classic network, that did happen, so that account still has that balance, but they have moved it to some extent. They've tried to get it off and go through exchanges, so they've turned into some Bitcoins as well. But generally, they still have most of that Ether in their account. I mean, everybody knows that account, so it's being watched by exchanges, but they don't have to do anything. I mean, they can divide their time. That Ether isn't going anywhere, so yeah. More recently, we had the multi-sig bugs. So Parity Tech wrote an Ethereum client and also other software. They wrote a multi-sig wallet. The first one that they wrote had a vulnerability that someone exploited. It was a very simple thing. It just meant that you could effectively reinitialize a wallet and take control over it and point at it, give yourself all of the funds that the wallet has. As soon as it was realized that this happened, somebody started doing it and got away with about $30 million. When that happened, another group of people called the White Hat group, so the good guys, went in and exploited the same thing to all the other wallets they could find to drain those the money and then tried to return that to the right people. But the attacker still got away with about $30 million worth. And then sadly, after that happened, another attack came along on that same wallet, which was slightly more subtle. Effectively, someone self-destructed a library that was being used, and it froze the multi-sig wallet, and it meant that Ether that was contained in that wallet could not be used, which was slightly ironic for Parity, because they had a spin-off called Polkadot, which had done a crowdfunding. They had, I think, about $90 million in their crowdfund held in a multi-sig wallet. That is now frozen. They'll never get that money out. But altogether, about $150 million has been lost, and yeah, it's gone for good. It is possible you could do a hard fork to get the money out, but when this has been suggested, in general, the Ethereum community has said, no, we're not going to do that. We've already had one hard fork for the DAO, and we don't think that's a good idea to do it again, so that money is lost.
I stumbled upon some message thread where the guy who locked the funds claimed that it was an accident by poking around his kill. Is there any more that you know?
I don't know. I mean, yeah, he claims it's an accident, and it's made a great meme as well for the shrug thing. You know. I'm not sure that it was an accident. So I don't know, but yeah, I haven't heard any difference. Okay, that's all of my talk. If you want to contact me, or if you want to find out more about XAIN, our company, you can come. There's the contact details for us, or you can come talk to me or the two Roberts, our developers here. Thank you for your attention. If you have any more questions, please let me know. Yeah, go.
What will happen if we go 10 years ahead? We will have millions of smart contracts in the network, and maybe half of it will never be executed. Isn't this a problem? Or if the one who issued it died, the smart contract still lives on, he didn't make a self-destruction or whatever?
Yeah, definitely. And so I think the Ethereum mainnet is probably bloated by huge amounts of people who have written token contracts, because they're very simple, and they've just forgotten about them and just left them there. So yeah, there's a huge amount. This affects scalability. So there are ideas that maybe you'd want to archive the blockchain. You would perhaps take a checkpoint of it, put the whole thing somewhere trusted, but most people wouldn't have that. They would just have the most recent blocks. But yeah, it's a definite problem. And like you say, so if someone does a smart contract and has control over that contract and then loses their private key or dies and doesn't give their key to somebody else, yeah, it's gone. Yeah, so, yeah.
What's your opinion on just the languages? Is Solidity too powerful for its own good? Or people just don't use it properly?
Yes, but
Bugs you can write in Solidity are just it's just insane that can happen, basically.
Yes, and I really welcome efforts that are going into making things more secure. So there's a lot of research going into formal methods to being able to prove what your code is going to do. So I think Solidity is improving. I would like to see functional languages on there that would have less side effects. What it can do, though, that is the idea of Ethereum, that it should be a Turing complete language. So it does have to have that power, but I think we need to put a lot of more effort into documentation of good practices. But there are some good things. So there's the Open Zeppelin project that have examples of that you can use. And they have been, they're open source, they've had a lot of eyes on them, so you can be quite sure they're probably safe. So yeah. Go on. Yeah.
What do you think of Tezos' approach to use a camel and then maybe have something that is more opening to formal reasoning that you could?
Yeah, I'd love that. I would love that.
But
certainly.
That would not be Turing complete. That's actually what they claim, or what they say, what they postulate. That it should not be Turing complete, so that it is actually open to formal proof.
Well, you can do formal proofs on Turing complete languages. I mean, but it is difficult, and yeah. In theory, yeah.
Isn't there this? I forgot the technical term, but that you cannot prove that
there's the halting problem.
Yeah.
Okay. Yeah, there is a halting problem, but you can still do reasoning about languages. But you can't reason about everything, perhaps, but there is still work doing that. So people are developing for traditional languages. They do formal proofs for that. But so I definitely welcome that. I would love to see it more, but it is very difficult. Yeah. Hi.
Another question about the different languages.
Yeah.
Now we have more and more tokens or coins which say they have a lot of different languages or agnostic. But are they really different languages or just using their syntax? Because they don't, or do they use something language specific, like threading or even pointers or anything like this?
So on Ethereum, no. So the higher level languages, they compile into bytecode, so it's going to be exactly the same. So they don't have anything specific. Things like threading is not allowed. Pointers, no. Not
specific things like a Neo or any others? Do you know them?
That will just be in the higher level, I guess. So they do try to make things more secure, I think. But other than that, I don't know of anything. And then it will compile into the same bytecode in the end. So that's talking about Ethereum. Of course, other blockchains do things differently. I have very big doubts about blockchains that claim that they can use languages like Java or Golang and implement those directly on a blockchain. I think that's going to be very problematic because you need consensus, and all the things like doing random numbers could happen with those languages. So I have my doubts about that, but those are the areas where you would see other things. Yeah.
Is it possible that the development of Solidity or other different languages reactivate or influence old smart contracts? Because I'm from financial business, and they had in America the problems with high frequency trading. They put up new code, new trading algorithms that reactivated old code they had on the server. They spent $450 million within a few seconds. The company is dead.
Yeah.
Is this possible that new code could influence the old smart contracts or something like that?
Well, contracts can call each other, so you can call any contract that you can find on Ethereum, you can call from within your own contract if you want. But I think that will probably be deliberate. Yeah, generally speaking, it will be deliberate, but yeah. Go on. Yeah.
Is it that the chain code on Hyperledger is
Yeah.
actually written in Golang?
Yeah, you can use Golang, in chain code, yeah.
Because you just mentioned that you cannot imagine that language.
Yeah, so I have my doubts about whether these are really going to work very well. Just because I think that if you need things to be deterministic, then using already an existing language that has lots of libraries and lots of functions that are not deterministic, I think it's very hard to go from that approach down to making it deterministic, whereas the approach I prefer is to start with something that is very basic and very restricted, and then to add that to that slowly, and each step you make will still be safe. But we'll see. We'll see how it goes. Yeah. Okay, are we done?